Hey there, Tierney from Monroe Community College here, and today we're going to learn how to balance redox reactions using the half reaction method. Now, we have seen redox reactions that are able to be balanced in the normal way, where you just add coefficients, but right now we're going to deal with more difficult ones that actually exist in acidic conditions. So you know that you're going to use this specific method when I specify one of two things. Either I'm going to ask you for the half reaction method of balancing, or I'm going to specify that the reaction occurs in acidic conditions, much like this one that we're going to do right now. So this says balance the following equation in acidic solution. So we know that we're going to need to utilize that acidic solution, and you'll see why that's important in a little while. So here's our equation. It involves two ions, C2O4 and MnO4-, and we're going to produce carbonate CO3 and manganese oxide, MnO2, which is a solid. In these equations, I'm okay with you taking off the abbreviations while we balance, because these are pretty lengthy. This is a lengthy process, and so this can just save you some time. So let's just dive into it, since this involves a lot of steps. So our first step that we're going to do is we're going to write each half reaction separately. There's an oxidation and a reduction step. We'll talk about how to tell which one is which later. So our first thing is we're going to kind of color code to see which one's involved in which. So we know that the reactant and the product that each involve carbon, those are going to go together, and the reactant and product that involve manganese, those are going together. So we're going to separate that out into two reactions, and you write those actually physically separate from each other. The second step that we do is we need to balance all elements except for oxygen and hydrogen in each half reaction separately. So here in our first reaction, the only element that we have that isn't an oxygen or hydrogen is a carbon. We have two on the left side and just one on the right side, so we're going to add a 2 in front of our carbonate ion. That balances our carbons. In the second reaction, it's just manganese, and it looks like we only have one manganese on each side, so we don't need to do anything. Don't worry about the oxygens yet. That is actually going to be in the next step. So in step 3, now we have, I'm continuing on. So now we're going to balance oxygen. Oh look, I have a typo. That should be a little 2, shouldn't it? By balancing H2O if necessary. So let's look at our first reaction. We have 4 oxygens on the left side and 3 times 2 oxygens on the right side. So we have 4 on this side and we have 6 on this side. So I need to add some water. So I need to add, it looks like 2 waters. So I'm going to add 2 waters. To this. On the bottom we have 4 oxygens on the left side, 2 oxygens on the right side, so I'm going to add 2 H2Os here. Now we have our oxygens balanced. Step 4. Now we are going to balance our hydrogens by adding H plus if necessary. This is where the acidic condition comes into play. The H plus ions released by the acid in your solution is actually going to aid in the redox reaction. And so now we're going to balance our hydrogens by adding those H pluses in if we need them. So in our first reaction we have 4 H's on the left side and 0 on the right. So we're going to add in 4 H pluses on the right side. In the bottom we have 4 H pluses on the, well, we have 4 H's, hydrogens, not H pluses. We have 4 hydrogens on the right side, no H pluses on the left side, so we're going to add our 4 H pluses to the left side. Let's go on to step 5. So now we have all of our atoms balanced. Hydrogens, carbons, oxygens, and manganese. So now on each of these, we're going to balance the overall charge. That overall charge needs to be balanced, and so we're going to do that by adding electrons. These are the electrons that are going to be involved in the actual redox reaction, where one reactant is going to donate electrons and one's going to receive them. So what we should find is that if we balance our charges correctly, one reaction should have them on the left side and one should have them on the right side, so that we have a redox reaction, a reduction as well as an oxidation happening in a redox reaction. So let's look at our charges. On the left side of the first reaction, we have, we have a neutral and a 2-, so we have -2 charge. Over here we have 2 times -2, that's -1, and that's +4 plus, so that's a neutral charge. So if this is a neutral charge and this is a negative charge, we're going to add 2 electrons so that both sides have a -2 charge. Now we're only adding negative charges, so you must balance it in that way. Let's look at the bottom. We have 4 H pluses, so that's +4 charge, and a manganate, which is a -1 charge. That gives us an overall charge of +3. Sorry about that. It's a +3. And this is all neutral. So we need to add 3 electrons to this side in order to make both sides neutral. So it doesn't matter what both sides add up to as long as they add up to the same. So in our top equation we got both sides to be -2. On the bottom equation we got both sides to be neutral. Notice that I abbreviate an electron as E-. Our next step, step 6, is now we have our 2 reactions, and we're going to multiply each half reaction by a factor that gives an equal number of electrons in each. Basically, we want the same number of electrons, so in this top reaction, we're giving up electrons, 2 electrons. In the bottom reaction, we're accepting 3 electrons. In order for these 2 equations to balance out, we need to have them donating and accepting the same number of electrons. So what we're going to do is multiply both reactions by a whole number that will give us the same. So basically we're finding the lowest common multiple of 2 and 3, which is 6. So we're going to multiply the top equation by 3 and the bottom equation by 2. So this is going to give us 6 H2Os plus 3 C2O4 2-, and it's going to give us 6 CO3 2-, 12 H plus, and 6 electrons. In the bottom equation, now we're going to multiply everything by 2. So we have 6 electrons, 8 hydrogen ions, 2 manganate ions, permanganate ions, 2 MnO2 or manganese oxides, and 4 waters. So now we have 6 electrons and 6 electrons. This is what your goal is, to get those electrons the same number and on opposite sides of the equation. And this gets us to our last step, which is step 7, which is we're going to add the half reactions and cancel out identical species. If done correctly, we should end up with 0 electrons in our equation. So our electrons will cancel out. Now, let's add these up. Our waters, we have 6 on one side, 4 on the other. So these 4 are going to cancel out and leave us with only 2. So we have 2 waters plus 3 of the C2O4 2 minus, plus, let's look at our H pluses. Those are actually going to cancel out. Do they actually cancel out? Let me look. Oh, look, I have a typo. That should be a 12. So let's change that to a 12. I didn't think they canceled out. So these 8 cancel out, and we're left with 4 on the right side. So that cancels out to 4. Sorry about that typo. Okay, so we don't have any H pluses on the left side because they all canceled out, and we have 2 MnO4 minus. This is going to give us 6 carbonate ions on the right side, plus 4 H pluses, and I'll just write this down here, and 2 manganese oxides. It's okay for your answer not to contain any of the abbreviations. I'm fine with that because these problems are so long. I'm more concerned with your ability to follow all of these steps. So here is our answer. 2H2O plus 3C2O4 2 minus plus 2 MnO4 minus gives us 6CO3 2 minus plus 4H plus and 2 MnO2. So there are lots of steps to this problem. The last step that you should do is really check your answer and make sure that all the charges add up on both sides. So let's do that right now. So we have 3 C2O4 2 minuses, that's a -6 charge, and 2 MnO4 minuses, that gives us a -8 charge on the left. Here we have 6 CO3 2 minuses, that's a -12 charge, and 4 H pluses, which is +4, that also gives us a -8 charge. That's a really great way of checking your work at the end of these problems. Let's go over the problem steps again. So first, we write each half reaction and balance them separately. The first thing you do is you balance all of the elements that aren't oxygen or hydrogen. The next thing you do is you balance oxygen by adding water, and then you balance hydrogen by adding H+. Next, you balance the overall charge by adding electrons. Next, you multiply each half reaction by a factor that gives an equal number of electrons in each. The electrons should be on opposite sides of the equations. Next, add your half reactions and cancel out all identical species. The electrons will cancel out if you've done it correctly. And don't forget to check by adding up the charges on both sides of your final equation and making sure that they're equal. So these are a lot of steps, and I want you to go back through if you have any questions, because right now I want you to try this out on your own. I have an equation for you to balance. It's in an acidic solution, so you're going to use this half reaction method. We'll be practicing a few more of these in class, and I'll be going over any questions you have. And I know that these can be kind of difficult. So try this example by yourself, get through as many steps as you can, and be ready to discuss your solution or your questions in class. See you then.